Hi everybody, let's talk today about what was happening in the phenomenon we looked at the other day where we pulled two pieces of tape off the table simultaneously. Here is what that experiment looked like. Inch pieces of tape side by side on the table. I'm going to rip them up at the same time and then bring them close together. So when you had two pieces of tape on the table and you pulled them up at the same time off the table, they repelled each other. The reason why, we can look at this animation here. So it was basically a friction event when you did that ripping off the table, not so different than when I rub a balloon on a sweater. See how the electrons have transferred from the sweater to the balloon. And the sweater would be kind of like the table and the balloon would be more like the tape. And we did that with both pieces of tape at the same time. So if you have the two pieces of tape and they're both negatively charged, you bring them close to each other, they repel each other. So we're going to draw a picture or a model of what was happening with the tape. So we know all materials are made up of atoms. So if I was going to represent that table surface, initially it would have equal numbers of positive and negative charges because it's made up of atoms, and most atoms are neutrally charged. Okay, so that means that the tape also, in experiment 1, the tape was side by side like this, and it's also made up of atoms. So I'm going to draw its starting atoms as well. Obviously, there'd be a lot more atoms than this in reality, okay? But we're just trying to represent, in general, what's happening. So both the table and the tape are neutral here in step 1. So before that first friction event, everything is neutral, just like we saw in the animation. In step 2, we have a friction event, and we are pulling the tape off the table, and we're going to basically rip some of the electrons that were on the table, and they're going to now end up on the tape. So I'm only going to draw the tape here, and it still has its own protons. I'm just using one to represent the atoms, and initially it had one negative charge each, but I'm going to say now each piece of tape got an extra electron from the table. Okay, so now these both have a net negative charge, an overall negative charge. What does that mean? That means that they will now repel each other if they are brought close to each other. And that is what we indeed saw. Okay, it's because they've got a net negative charge, this causes them to repel. Now the second scenario is a little bit more difficult to explain. Remember, in that scenario we had one piece of tape on top of the other piece of tape, and then both of them were attached to the table surface. So when you first rip it off the table, that's your initial friction event. So collectively these two pieces of tape now have a net negative charge. So there was a friction event coming off the table, rip. Now these have extra electrons that came from the table and are now on the tape. And when I rip them apart, I'm going to have a second friction event. And now those electrons, extra electrons, are going to be transferred just to one piece of tape. And they will attract each other. You see that, how they're pulling towards each other now? Okay. So here's a picture to represent that process. So experiment number 2 started very similarly, except that these two pieces of tape were on top of each other. I'm not a great artist, so it's hard for me to represent it, but they were literally on top of each other on the table. Okay, and everything was still neutral to begin with. Our next step is we pull the two pieces of tape up simultaneously simultaneously off the table. Okay, so we've got our two pieces of tape. They're still attached to each other. Okay, and they have collected some extra electrons from the table in the initial friction event. Okay, so these are net negative. Okay, but they're still on top of each other. So in experiment 2, we had one more step. We took these two pieces of tape that were on top of each other, and then we ripped them apart from each other. And when we did that, we had another friction event. So again, the protons don't move in static electricity. Only the electrons can move because they are on the outside of the atom. In that second friction event, the extra electrons that were on this piece of tape get transferred to that piece of tape. And so now we're left with something that's got a net positive charge and something with a net negative charge. The only thing I don't like about the picture I just drew is I wish I had initially started with more protons drawn here, because here what's happening is that we wouldn't have transferred all the electrons that are on the object, but I realized if I left one behind, this would be looking like it's neutral. So just be aware that this is a little bit incorrect in that not all the electrons usually transfer during static electricity. Usually it's just the excess electrons that are transferred. Okay, so rip, both pieces of tape are negative. Rip, now one's positive, one's negative, and that's why they attracted in experiment number 2. Hope this helps. Give it a thumbs up if it helps you to understand what was happening in that phenomenon, and have a great day.